Hi everyone, so today's video is about Intruder. We're continuing on the Burp Suite series after taking a look at the proxy and repeater. Now we will be talking about the Intruder module. So what is Intruder? So first we need to understand what is fuzz or fuzzing, fuzz testing. So fuzzing is an automated testing method where we inject inputs into the system that are invalid, malformed, or unexpected. And that is to reveal defects and vulnerabilities or if something exists. For example, we can fuzz for endpoint in a web application, and that would mean trying to go to different pages in a domain, and those pages come from a word list. So Intruder is in fact a fuzzing tool, which means it takes a request and use it as a template to send many more requests with slightly altered values automatically. So for example, let's say we have this login form and we want to attempt some fuzzing here. So what we do is first capture a request containing a login attempt, and then we would configure Intruder to swap out the username and the password with word lists, which will allows us to brute force the login form. So Intruder can be used to fuzz for subdirectories to endpoints or virtual hosts. This functionality is very similar to tools that we've seen, which are wfuzz and faf. So for automating requests, Intruder is extremely powerful. However, there's one problem, and that is Intruder is heavily rate limited in the community version. So if you want to use it at its best, you need to go for the Burp Pro version to do the fuzzing or brute forcing, but you can use other tools for fuzzing and brute forcing like the ones that you talked about, like wfuzz and faf. Anyway, so let's take a look at the Intruder interface. So the first view we get is something like this, and it's the target. So we are on the target subtab for the Intruder tab. And on this subtab, what we can find here is the target. So we can configure the details of the target for the attack, the hosts, the ports that we are going to use, and if we'll be using HTTPS or not. And all this is after we assume that we sent a request from the proxy to Intruder. If you don't know how to do that, we'll see that a bit later, or you can go back and watch the Burp proxy video that is linked down below. So there are 4 other Intruder subtabs. There's the position, and here it allows us to select an attack type and also configure where in the request template to insert our payloads. Then there's the Payloads tab. So this will allows us to select values to insert into each position, and this will be using either word lists, regex, and many other ways to do. So how these get inserted into the template depends on the attack type we chose in the Positions tab. This subtab also allows us to alter Intruder's behavior with regard to payload. So we can define pre-processing rules to apply to each payload. So for example, add in a suffix or add in a prefix or using a match and replace type of rule, and so on and so forth. Then there's the resource pool. This allows us to divide our resources between tasks. However, this is not really useful in the community version, but in the Burp Pro, that would allow us to run various types of automated tasks in the background, which is where we wish to manually allocate our available memory and processing power between these automated tasks and Intruder. And because we don't have access to these automated tasks in the community edition, there's no point in using this, so whatever. And then there's the options. This is where we will be able to configure attack behavior. So the settings here apply primarily to how Burp handles results and how it handles the attack itself. For example, we can choose to flag requests that contain specified pieces of text or define how Burp responds to redirect responses. So we'll take a closer look at these subtabs now. So let's look at what are the positions that we've talked about. When we are looking to perform an attack with Intruder, the first thing we need to do is look at positions. And the positions are there to tell Intruder where to insert payloads. So if we look at the position tab here, what we can notice are these silk rows, these squiggly double S, if you want. So these silk rows are added automatically to the payloads by Intruder, but we can still clear these by using the clear button, or we can add these by selecting something and using the add button, or we can use the auto button to add the silk rows automatically to what Intruder thinks that they could be positions for that. So now that we've talked about positions, we need to talk about attack types. So there are 4 different attack types. We have the sniper, the battering ram, the pitchfork, and the cluster bomb. And we'll look into each one of them in more details. So let's start with the sniper. So when we want to conduct a sniper attack, we need one set of payloads, and this can be a single file with a word list or a range of numbers, and this is also called a payload set. So Intruder takes each payload in a payload set and put it into each defined position in turn. So how it will work, let's say that we have this template. So this is a request that was intercepted in the proxy and we sent to Intruder. And there are 2 positions, one in the username and the other for the password body parameters. So in a sniper attack, Intruder will take each position and substitute each payload into it in turn. So let's say we have a word list with these 3 words, Burp Suite and Intruder. What Intruder is going to do in a sniper attack is that for the username, it will start by putting each word of the word list in the first position while leaving the second position as it was. That's why you get username equal burp and password still exploited, didn't change. Then username changed to the second word in the word list and the password still hasn't changed. And then the username used the third word in the word list and the password hasn't changed. Once this is done, it goes and take the second position and modifies it with words in the word list. So this time the username won't change, it stays pentester, while the password goes through all the words that are in the word list. And so here we end up with 6 requests. So the number of requests made by Sniper are equal to the number of words that are in the word list, multiply that by the number of positions. So this is really good for single position attacks like password brute forcing or fuzzing API endpoints. The second type of attack we'll talk about is the Battering Ram. So the Battering Ram, just like Sniper, needs one set of payloads. And it will put the same payload in every position at the same time. For example, we are going back to this. Here Intruder takes each payload and substitutes it into every position at once. So if we had the same word list, we'll end up with this. Notice that the values for the parameters username and password are the same for each request. So request number 1, username equal burp, password equal burp. First word in the word list. Request number 2, username equal the password, which both equal the second word in the word list. And request number 3, both username and password are equal to the third word in the word list. The third type is the pitchfork. So what's a pitchfork? It uses one payload set per position with a maximum of 20, so 20 position, which means maximum of 20 payloads, and it iterates through them all at once. So for example, if we go back here, we have 2 positions, so we need 2 lists for the pitchfork, one for the username and one for the password. So let's say that we have the usernames Joel, Harriet, and Alex, and let's say that these 3 have had their passwords leaked before. So we know that Joel's password is the first one, and Harriet's password is the second one in the list, and Alex's password is the third one. So we can use these 2 lists to perform a pitchfork attack on the login form. And the request that will be made will look like this. So the first word in the username word list will be added to the username, and the first word in the passwords word list will be added to the first request in the password field. And same for the second and third. This is repeated until one or all of the lists run out. So the first list that runs out, Pitchfork stops working there. So Pitchfork stops as soon as one of the lists is completed. For example, if we have one list with 100 words and another one with 90 words, then Intruder will make 90 requests. So this is useful for attacks like credential stuffing. Now on to the last attack type, which is cluster bomb. So cluster bomb, a bit like Pitchfork, allows us to choose multiple payload sets, one per position, up to 20. However, instead of iterating through each payload set simultaneously like Pitchfork, it iterates through each payload set individually, which makes sure that every possible combination of payloads is tested. So if we go back to our example with the usernames Joel, Harriet, and Alex in that username word list, and the passwords that are in the password word list, we have 3 on each. What is going to happen is we'll end up with 9 requests. How it will do that is the first position will have all the usernames, as you can see, Joel, Harriet, Alex. But for the password, we'll just use the first word that is in the password list for the 3 different usernames. Once we've done with all those 3, we go back to the first username with the second word in the password word list. Then the second username with the second word in the passwords word list. Then the third username with the second word in the passwords word list. And so on and so forth until we do all the words. So all the combinations possible are done. So you have to know that the cluster bomb attack will generate as many requests as the number of words in the word list multiplied by, so it will be equal to the number of words in each payload set multiplied together. So here we have 3 words in the first payload set and 3 other words in the second, which means we end up with 3 multiplied by 3, and that's why we have 9 requests. So this type of attack is also extremely useful for any kind of credential brute forcing where username is unknown. And now that we're done with all the attack types, let's go and have a look at the payloads. So the payload subtype is split into 4 sections. We have the payload sets, the payload options, the payload processing, and the payload encoding. So the payload sets allows us to choose which position we want to configure a set for. For example, for a single payload set attacks like sniper or battering ram, there's only one option. But for multiple payload sets attacks like Pitchfork or cluster bomb, there's one item per position. And for 2 positions like in username equal pentester and password equal exploited, the first payload set is for the username field and the second refers to the password field. It also allows us to configure what type of payload we would like to use. It can be a simple list, which lets us load in a word list to use, or recursive grep, or also numbers and username generator, and many other types of payloads. Then there's the payload options. So here it will depend on the payload type selected. So for example, for a simple list payload type, we would end up with something like this. We can do this manually using the add text box or paste lines in with the paste or load from a file. The remove button removes the currently selected line only, and the clear button clears the entire list. While a numbers payload type would be looking like this. So it gives us the choice to have range. Are the numbers sequential or random? What is the range from to? And the number format, is it decimal or hexadecimal? Now we have the payload processing. So this allows us to define rules to apply to each payload before being sent to the target. For example, we could capitalize every word or skip the payload if it matches a regex. So this payload processing isn't something that you will be using all the time, but when you will need to use it, you'll appreciate the fact that it is there. And finally, the payloads encoding. So in this section, it allows us to override the default URL encoding options that are applied automatically to allow for the safe transmission of our payload. So sometimes it's beneficial to not URL encode and save characters, which is where this section comes in. So we can either adjust the list of characters to be encoded or uncheck this checkbox. So now that we've talked about all the theory behind Intruder, how it's used, and every subtab that exists there, and attack types, let's go and do a practical example. Let's go to the support login page and look at the page source. So if we look at the page source and we read it, it's like there's a post, so it will be a post where we have to put the username and the password, and there's no protection, or at least from this site. And there's also something else. So because there is no protective measures that we can see, at least, we could try to use this form and do a cluster bomb attack for a brute force, for example. However, there's something that happened. So the Bastion hosting was hit with the cyber attack 3 months ago. And all their employee usernames, emails, and plain text passwords were leaked. So the employees were told to change their password immediately, but we all know that there will be some who won't. And we have a list of known usernames, and each username is associated with a password, which is nice. So from that, we can use a credential stuffing attack. I already downloaded the words lists, And so to connect here, I'm going to use the usernames and passwords file lists. So the first things we need is launch Burp. So once we have Burp Suite open and intercept on, so once we have the intercept on, what we are going to do here is send in a test username just to get it here. So as you can see here, we have the username and the password. Now we can send it to Intruder. I could have used also the Control I. So once it's in Intruder, as you can see, the positions for the username and passwords are already set. So here I need to use the Pitchfork attack, as we'll be having like 2 different payloads. Now that this type of attack is done, we go to the payloads. There's 2 payload sets. The first one, if we go back to position, is the username one, and the second one would be the password one. So both of them are simple lists. I'm gonna load the first one, so I'm loading the first one, which is here, the username. Now going to the second position, which is also a simple list type of payload, and here I'm loading the second, which is the password. Now that this is done, what I'm gonna do is start the attack.
A few moments later.
Now that the attack has been done and is finished, we can look at the response. So if we go here, let's see if there is anything like status code that is different. No, every status code is a 302. So Mozilla Developer WebDoc says this response code means that the URI of the requested resource has been changed temporarily, and further changes in the URI might be made in the future. Therefore, this same URI should be used by the client in future requests. Anyway, so there is no difference in the status code, but the other thing that we'll look at is the length of the responses. As you can see, almost every response has a length of 674. However, there's one with a length of 593. And if you see the difference here, so this one, this one, you should be redirected automatically to target URL, which is support login, the web page where we were, while this one redirect us to support. So that's why there is a difference in length, and that is probably also why this is the password. So the right password for the username m.rivera. So let's log in with this account. And here we are. And we get to a challenge. In the task before, we were able to gain access to the support system, and now it's time to see what we can do with it. So what we see here is that there is the support system with tickets. We have assigned tickets, and if we click on a ticket, and if you click on a ticket, this ticket opens, and there is a number here. So if there is a number, a thing that we could do is so it's probably an ID number. So we could try and fuzz the number to see what would happen. So there are a lot of things that could happen. So firstly is if the endpoint has been configured rightly, like no problem, no security problem, we will be able to only access the tickets that were assigned to us. But if not, that means there is an IDOR. So an IDOR stands for Insecure Direct Object References. And if you don't know what it is, you can look at what it is on the description box. There's a video for it, or you can just follow with me right now. So going back to proxy, intercept on, just reloading this. Now we'll forward it to Intruder with Control I. So we go back to Intruder, and clear this. We want this number to be the position where the attack will be done. And because we only have one position, the attack type that we are gonna choose is the sniper one, as that's the one that is the best suited for it. So let's go to the payloads, and here, instead of simple list, we want numbers. And as you can see, there is only one position, so there is only one payload set. So we could change here, so from sequential, we can start from 0 to 100, or we can start from -1 to see if there's something. Let's start from -1. So from -1 to 100, and we want a step of 1. So it goes from -1, 0, 1, 2, 3, 4, and so on and so forth. Let's start the attack. And let's wait for an answer.
A few moments later.
So now that the attack has been done, what we are gonna do is look at the status code. If we go back to the tickets that have been assigned to us are the number 6, 57, and 78. So let's look at what we have here. So 6 was assigned to us, 57 too, but 47 wasn't. So let's look at it. We can look here in the response what we get. Let's open this. Let's have it bigger. So already here, normally this shouldn't be coming to us. We shouldn't be able to access it. Then there is also 78 it's something that was assigned to us. So let's look at the 83. And we find the flag here. We can also look at them here. So 83, for example. And here we go. Or 47, I think. This is another one that shouldn't be coming to us. Okay, now that this challenge is completed, let's try and do a CSRF token bypass. So CSRF stands for cross-site request forgery. So this challenge is slightly harder than the first one. So it's still a variant of the credential stuffing attack that was carried before. However, there are measures that are in place to make the brute forcing harder. So let's go back to the website, and this time in the admin login portal. So here we go. Put in the intercept on. Put in any type of, let's put just admin. Now we have, this request has been intercepted. What we can see is there is the username, the password, and a login token. So let's review also the response. So this is the request that was sent with username, password, and login tokens, and this is the response that we got. And if we look at the page source, we can see that this is a post method that will use a username and password and also the login tokens. So we have the same username and password fields as before in the example, but there is also a session cookie that is set in the response and a CSRF token which is included here in a hidden field. So if we refresh this and look at the new login token here, it's not the same value. This starts with 47 and this one starts with 44. So in other words, every time we attempt to log in, we will need a unique value for the session cookie and the login token, which are hidden. So same with the session cookie. If we look at the here, we have this session cookie, and if we reload it, try it again, it will be a new one, as you can see. Here they are. So for this, we need to use what is called macros. So it's a short set of repeated actions to be executed before each request. So this will be able to grab a unique session cookie and match in login token and substitute them into each request of our tag. So first, let's send this to Intruder. Now that it is in Intruder, let's clear everything first. And let's just put the username and password in a position. Now we'll use a Pitchfork, same as before. As the other two positions, which are login token and cookie session, will both be handled using the macro that we're going to define. So now that this is done, we go to the payloads, same as before. We load the username. Now for the second payload, we load the passwords. So now that we've set the payloads and everything, we need to find a way to grab the login token and session cookie that change all the time. The problem is we could have used recursive grab, but recursive grab wouldn't work due to the redirect response. So we need to build a macro. So here, what we are gonna do is we go to the project options, and in the project options, we go to the sessions, and once we are here, we scroll down to the macros. So here we add a macro, we go back, we go here, we find one with the get admin login, so what we were searching for. So we name it this. Once it is named, we go back to the session handling rules, we add one. In the scope, we put, so we need it for intruder, which is why we put it here. Now, you can, if you already put the URL in the target scope, you use suit scope. If not, you can add here the URL. Sorry. Okay, mine is already here. And we need to tell it which macro to use. So we are going to use this one. And here, update current request with parameters matched from final macro response. So update only the following parameters. We want the login tokens. Sorry. So we want the login token. And update current request with cookies from session handling cookie jar. We wanted to update only the following cookie. It's the session one. So we got these from the requests and response we got before. Now that this is done, we can go back to Intruder and start the attack. So as you can see here, as of now, all the status code are 302, which is the same as the first example, I think. The same as the example earlier. However, the lengths are a bit different.
A few moments later.
Now that this is done, so if we go look at the status codes, they are all 302, so nothing to look here. But we can look at the lengths, and in the lengths there are a few that are different, that are really shorter than the others. As you can see here, majority of the lengths are around 750. All of these are under that, and if we look at the responses, you see that in the response it says you should be automatically redirected to the target URL and it's to admin. However, for the ones that are 700 and something, you are redirected to admin login, so you go back to the login form. So let's take one of them. Let's go with this one. So I'm copying, so here. And let's see. Oh, no. So it says forbidden. Okay, let's try another one. Let's try this one, which has a length size that is completely different. And yes, even though this is the answer, and we are in the admin homepage. That was it for today's video, which was about Intruder, how to use it, how to define macros, and so on and so forth. You'll find in the description below all the links and to resources that I used for this video. I hope you enjoyed this video. Thank you for watching, and until next time. Bye!